Okay, find the magnitude of each of these vectors. Okay, so the first one, a equals 3i plus 4j. Okay, so remember back now a few questions. Magnitude is interested in the size of it, right? Now you can draw it if you want, going across 3, up 4, and create a triangle. Okay, and you can work out what the hypotenuse is then. Okay, you're using Pythagoras' theorem. You could just remember the process. Okay, just realize that's going across, that's going up. So you've got to square these two sides, add them once they're squared, and then square root it to get the magnitude. And remember, to work out the magnitude of the vector, when you're doing that, you need to use this notation. Okay, put bars around it, and that tells you that you're actually working out the size of it. Direction now is of not of any interest to it. You're working out the size of it, so the i's and j's disappear. So remember, you square that, and then you square root the answer, and of course that comes out quite nicely to be 5 in that case. Yes, the 3, 4, 5 triangle. So that's the magnitude of it there, right? That's the size of this vector. It's of length 5. You can draw it accurately if you want, and it will be 5 centimeters. Okay, second one. So what have we got? B equals to 6i minus 8j. So again, you can draw that triangle if you want. You're going across 6 on you in the x direction, down 8 in the y direction. Okay, but when you look at the triangle and you want to work out the size of that hypotenuse, well, you're going to square both sides. Okay, as I said, the minuses I'm not interested in. The minus just tells me the direction. It just tells me it's going down. The actual side is of length 8. So you don't need to have it in here. But if you do, put it in a bracket, and then when you square it, it won't make any difference, won't it? So you do that there, and that comes out to be 10, yeah? Okay. 3 then, the third one. So we've got, what have we got here? So we've got c equals to minus 5i minus 12j. So again then, the magnitude of this, okay, so you're going back 5, aren't you, and then down 12. So think of that triangle there. So it'll be 5 squared plus 12 squared. That comes out nicely again. Comes out to be 13. They won't always come out nice, okay? Sometimes they'll come out as a surd. You just leave them then as a surd, okay? You don't have to write it as a decimal and rounding it. You could just write it as a surd if it comes out like that. So in B then, it says that show that B equals to Ka, where K is a positive integer to be found. So modulus of B, they're saying, is equal to, and again, another word for this, right, I haven't mentioned this so far, is the word modulus, okay? It just means magnitude, the size of it, right? So if I mention the word modulus, that's what I mean. I'm just referring to the size of it, with bars around there. So the modulus of B equals to Ka. Now I don't need to underline the K there because K is a constant, right? So there was a mistake there. I'll rub that out. And we want to show that. Well, what is B? Well, B is equal to 10, isn't it? And A was equal to 5. Okay. Okay, so if I substitute in the size of B and the size of A, okay, well then I can see that K, the constant there, is actually a positive integer, isn't it? K has got to be 2, isn't it? Because 10 is equal to K times 5. That means K has got to be 2, okay, which is a positive integer. Okay, now integer just means whole number. Okay, so in this case it is a whole number and it's positive, so therefore modulus of B is equal to K modulus of A, okay, where K is a positive integer. Okay. Okay, C then, determine the range of values of M such that M, the size of B, is greater than the size of C. Okay, so again, it's a case of substituting in here what we know. Well, the size of B was 10, wasn't it? Okay, we saw that. And the size of C, we can see there, is 13. So what are we going to do to get M on its own now? Well, I've worked out the sizes of these two. So to get m on its own, I've got to take that 10 over the other side, haven't I? Because I'm timesing here. When I take that 10 over, I divide. Okay, so there you go. M has got to be greater than 13 over 10. When they ask for the range of values, well, I found a range of values, haven't I? It's not going to just be a single value, it's going to be a range of them. M has got to be greater than that. Now, if you want, you can write it as a decimal if you want, because it's quite nice, isn't it? M has got to be greater than 1.3. So any value above that, that's the range of values that satisfy this condition there, because you know B and C are fixed values. There's the size of them, and then you can work out M has got to be greater than that for this to be true. Okay.